stands for. To read this notation, the double integral over r of 6y squared minus 2x dA. Okay, so that stands for a double integral of the function of two variables, 6y squared minus 2x, with a dx and a dy, and now the difference is that you do not have an r, and dA has been split up into two parts, dx and dy. You could think of this as a product of a little bit of length in the x direction and dy a little bit of length in the y direction, a product of two lengths giving an infinitesimal area. Since the r is missing, we need to describe limits of integration for x and y. We see them here. X, the first one, see, the inside definite integral, has limits 0 to 1, and y, the outside definite integral, has limits 0 to 2. Now, let me take a look at my instructions, number 15. Evaluate the double integral over the region. All right, so let's proceed with evaluating this. Okay, I'm going to use the fundamental theorem of calculus to anti-differentiate with respect to x on the inside here first. So I'm going to leave that there, and just write down an antiderivative of the old integrand of that with respect to x. Okay, 6y squared then is treated like a constant. 6y squared antiderivative of x. All right, minus 2x, antiderivative with respect to x, is x squared. Okay, that evaluate between 0 and 1. Okay, I can see that when I evaluate either of these two terms in here at 0, they're just going to vanish. So I'm just going to write out what happens when I evaluate at 1. 6y squared times 1 minus, and here I evaluate x squared at 1, so 1. All right, again, I should subtract the term that I get from substituting 0 into that expression, but that is 0, so I don't write it. Since you don't have to subtract 0 explicitly. Too boring. Now, antiderivative with respect to y of this integrand is, let's see, y to the third, 6 then divided by 3, I'm left over with a 2, and minus y that I evaluate between 0 and 2. That'll leave me with a 2 times 2 to the third minus 2, which is 2, 4, 8, 16 minus 2, which is 14. So, in the end, what I'm saying here is if R stands for a certain region described by the system of inequalities, then the notation, the double integral over R of this function, is another way of saying this double integral, which is the number 14.